this first question here, they just want us to find the radius and the center of the following circles. The only difference between all these circles is the way they're written. So this first guy, x squared plus y squared is equal to 144. This you have to be able to recognize. This is just a circle centered at the origin. So like if you have a graph like this, the circle will look something like this. The center is here at the origin because we have nothing minusing from either side, like in part 2, we'll say. So the center of part I, I'll draw it here. The center, I'll call it CR because C is a different thing in circles. CR, the center is going to be 0, 0. And the radius is just going to be the square root of 144, which is 12. So that's the first one done already. That's a very basic case. If you have an equation that looks like this, the center is just 0, 0, and the radius is just the square root of this fella. The second one now is a bit more complicated. We have x minus 2 squared plus 8, or y plus 8 squared equals 100. In this case, the center is going to be the negative of this number. Because if you remember, the general equation, if we have the center as hk, the equation of the circle will look like x minus h squared plus y minus k squared is equal to r squared. The most complicated part of this is the minus here. Students will get confused about that. All you need to know is if you have an equation that looks like this, just take the minus of the number and you'll get the center. So we have x minus 2. So the center coordinate for the x is going to be just plus 2. And then the center coordinate for the y is going to be minus 8 because we have a plus here. So you're taking the opposite sign of what's in the brackets to get the center. That's CR. And then the radius, again, is just going to be the square root of the number at the end. Square root of 100. That's just going to be 10. So that's the second one done. The third one is a little more confusing again. These are just 3 different ways you can write a circle equation. So like the first one is if it's at the origin. The other 2 are the same, but they're just rewritten differently. It's like if you expand these brackets out, kind of. So now, the third one, you need to divide the number in front of the x and the y by minus 2. So the center is going to be minus 4 divided by minus 2 and 8 divided by minus 2. So that's going to give you 2 and minus 4. So that's the center of the first guy. Now to get the radius of the third question, we have to remember that r is equal to the square root of g squared plus f squared minus c. And c is this last number here. It's going to be 19. So r is going to be the square root of g, which is the center coordinate, is going to be, well, technically it's minus 2, but minus 2 squared is just going to give us 4. Then we have f squared, which is going to give us 16. And then we're going to have the minus c, which is minus 19. So that's going to give us just the square root of 1, which is 1. So this is a circle with radius 1 centered at 2 minus 4. And that's that question done. The next question here, we have a line that intersects the circle twice. And we want to find the coordinates of the point of intersection. This is going to look something like this. If we have a circle like this and we have a line going through it, we want to basically find this point here and this point here. So how we're going to do that is we're just going to fill our line equation into the equation of the circle, and that's going to give us 2 values. So we have what? Y minus 2x minus 4 is, well, that should be equal to 0. That's the equation of the line. That intersects the circle. So now I'm just going to bring everything but the y over to the other side. So I'm going to say y is equal to 2x plus 4. Now we have the equation of the line. Same thing, we just wrote it differently. Now we're just going to fill that into the circle equation to get our points. So now we're going to have x squared plus y squared. Now we're going to change for 2x plus 4, all squared, minus 6x minus 8 times 2x plus 4, minus 11 is equal to 0. Expand the brackets, we have x squared plus 4x squared plus 16x plus 16 minus 6x minus 16x minus 32 minus 11 equals 0. That's a lot of stuff. Key here, I would always say, pick a different color pen and underline the like terms. So we have the x squareds there. We will have the x's here, x, and x, and then the rest are just the normal constant terms. So x squared plus 4x squared, we have 5x squared. We have 16x minus 16x minus 6, so we're just going to be left with a minus 6x. And then we have 16 minus 11, that's going to give you 5. Minus 32 is going to give you minus 27 is equal to 0. I think that should be correct. And now you could solve this using factorization, maybe. I think it's just going to be easier if you use the minus b formula. I'll grab a calculator. So here we're going to have a equals 5, b equals minus 6, and c is equal to minus 27. We just fill into the minus b formula. So x is minus b, which is going to just be 6, plus or minus the square root of 6 squared is 36, minus 4 times 5 times minus 27, all divided by 2 times 5. So we're going to have x is equal to 3, and when you do the minus, you're going to have x is equal to minus 9 over 5. And now, to get the y value, we can just fill into either the circle equation or the line equation. The line equation is going to be way easier. We already have y is 2x plus 4. X is 3. That means y is equal to 2x is 6 plus 4 is going to give us 10. And then we have x is minus 9 over 5. So multiply that by 2 and then plus 4. That's going to give us 2 over 5. So that is the equation, or the point of intersection of the line and the circle. It's going to intersect at 3, 10, and minus 9 over 5, 2 over 5. Boom, done. Here we have a circle centered at 3, 5, and it passes through the point 0, 8, and we want to determine the radius of this circle. And then we have to write down its equation. So always with circles, I would say, just draw a sketch of what we're dealing with. Center's at 3, 5, so center's here at 3, 5. And a point 0, 8 is on the circle. Just guess, say 0, 8 is here, like that. That means this here is going to be the radius. Now, how do we get the radius? It's just going to be the distance between those 2 points. So we just have to use our regular distance formula. D is equal to the square root of what? X2 minus X1. There we go. X1 squared plus Y2 minus Y1 squared, like that. This is very messy. But yeah, that's the equation we need. Just the distance between 2 points. So the radius is going to be the square root of, I'll say the 2 coordinates are up here. Why not? We're going to have 0 minus 3 all squared plus 8 minus 5. Oh my god, minus 5 all squared. So that's going to be the square root of 3 times 3 is 9. And then 8 minus 5 is going to be 3. Squared is just going to be 9. So that's going to be square root of 18. That means the equation of our circle is going to be, we can write it in whichever way we like. The easiest one, center is 3, 5. So we're going to have x minus 3 squared plus y minus 5 squared is equal to the radius squared, which is just going to be 18, not the square root of 18. So that's the circle equation. Okay, the next part of this question, we want to find, if there is a line tangent to the circle at 0, 2, we want to find its equation. Now, in my one, it's wrong. It should be 0, 2, but your one's going to be fixed, so it doesn't matter. But again, always draw a sketch of what you're working with. It's going to look something like this, probably. And that's going to be the point of intersection there, and that's the center of our circle. How do we get the equation of a line? We need a point, which we have, 0, 2, and we need the slope. We don't have the slope of the line, but we can get the slope from the center to the point. And when we get that, we can get the slope of the line because, again, it's a tangent line. The key with tangents, a tangent is always perpendicular. So, like, if we have, I'll draw it, like, if it's zoomed in, a tangent line is going to look something like that. It's going to be perpendicular to the center of the circle. It's going to be a right angle here. And that's how we can find out the slope of the tangent line. So, let's get the slope. We have the center is at 3, 5. And we have our point is 0, 2. So the slope formula, y2 minus y1 over x2 minus x1. Just fill in then, I'll say y2 is 5 minus 2 over 3 minus 0. So that's going to be, 3 over 3? So 1. So coincidentally, the slope is going to be 1. The slope of our tangent line, I'll call it ML, is equal to minus 1. So we have the slope of our tangent line. Remember, all we have to do is like, okay, this is just 1. So like technically it's like 1 over 1. So if we flip it, it's just going to be 1 still. But we have to change the sign. So we're going to have minus 1 here. Now, we use the line equation, y minus y1 is equal to m times x minus x1. And we just fill in our point. We have 0, 2 as a point. So y minus 2 is equal to minus 1 times x minus 0, because 0 is our x coordinate. Then we just simplify y minus 2 is equal to minus x, or y plus x minus 2 is equal to 0. Either of those are valid. And that's going to be the equation of the tangent line at the point 0, 2. Okay, this next question is saying we have to determine whether these two circles touch internally or externally. Always that's going to depend on the radius. So like if they touch externally, like this we'll say, that means the distance between their centers will be like the sum of their radii. But if they touch internally, so like something like this we'll say, that means that the difference in their radii will be the distance between their centers. So we're always going to need to get the centers of each circle first. So I'll call this guy here C1 and this guy C2. So the center of C1, just divide the thing in front of the x and y by minus 2. So it's going to be 2 over minus 2, and then minus 10 divided by minus 2. So that's going to be minus 1, 5. That's the center of the first circle. And its radius then, we do the square root of 1 squared is 1, 5 squared is 25, minus c, which is minus 10, so it's going to be actually plus 10. So that's going to be the square root of, what was that, 36? So that's going to be 6. So that's the center and radius of C1. I'll draw that there. Now C2, a bit easier to see. Its center now is just going to be minus 1 plus 7, because we just changed the sign of these two numbers. And its radius is just going to be the square root of 16, which is 4. Boom. Now, let's get the distance between their centers. So to do that, we use the same formula, square root of x2 minus x1 all squared plus y2 minus y1 all squared. The circles chapter is pretty difficult, but it relies a lot on the line chapter. So you need to make sure you're very comfortable with all the formulas from the line chapter before you can move on to circles. We're using the distance, slope, all that throughout the circles. Now, filling in square root, doesn't matter what one you call x2 or x1. So in this case, it's actually just going to be minus 1 minus 1. So that's just they're just going to cancel. And then we're going to have plus y2 minus y1. So that's going to be like a 7 plus 5. Or 7 minus 5 rather, squared. Like that. So those are going to cancel. So we're going to square root of 0 squared. 0 squared plus, that's 7 minus 2 is 7 minus 5 is 2. Squared is 4. Square root of 4 is just going to be 2. So the distance between the centers is going to be 2. But we had that the radius of one was 4 and the other was 6. So center 1, the distance between the centers is going to be 2. The difference in the radii. The distance in their centers we just got is 2. But the difference in their radii is also 2. 6 minus 4. So we know, because we're taking the difference in their radii, they must touch internally. If this answer here for the distance between their centers was, we'll say, 10, or no, not 10. Yeah, it would be 10. If it was 10, that would mean it was the sum of their radii. And that means they would be touching externally. But because it's the difference in their radii, we know they're touching internally. Okay, this last question here for the circle, we want to find the equation of the circle which passes through these 3 points. This is a pretty difficult question if it comes up in your Leaving Cert. It's difficult in that there's a bit of work to it, but it's actually not that difficult in reality. So all you have to do here, we have these 3 points. These are all x and y coordinates, xy, xy, and xy. All we have to do, we just fill into the circle equation. We don't even think, just fill into the circle equation. Each of these points, we're going to get 3 equations, and then we use simultaneous equations to solve for what all the things are. So I think it's easier if I just do it, and you can see. So the first point is 1, 2. Remember, I'll write it in red here. The circle equation is x squared plus y squared plus 2gx plus 2fy plus c is equal to 0. And that's for a circle with center minus g minus f. Minus g minus f. I'll draw it again. That's the trickiest part, that the center is minus g minus f. That's the trickiest part, that you might have to change a sign here and there. So 1, 2. 1 squared plus 2 squared plus 2g because x is just 1 plus 4f because the y is 2 and 2 times 2 is 4 plus c is equal to 0. So that's our first equation. Well, actually, we can simplify this. We can write this as 5 plus 2g plus 4f plus c is equal to 0. Now, next point. 5, 0. 5 squared plus 0 squared plus 10g plus 0f plus c is equal to 0. We simplify that to 25 plus 10g plus c is equal to 0. And the last one, we have 1 minus 8. So we're going to have 1 squared plus minus 8 squared plus 2g minus 16f plus c is equal to 0. And finally, simplify that, we're going to have 65 plus 2g minus 16f plus c is equal to 0. So all we've done here is we just filled into our equation. We have these three equations here, 1, 2, and 3. If I gave you these in x, y, and z, you would be able to solve them using simultaneous equations. Just this time we have g, f, and c. So what we're going to do is we're just going to do simultaneous equations and get g, f, and c. So what I'm going to do is I'm going to do the second equation. I'll go 2 minus 1. 2 minus 1 is in the second equation minus the first equation. When I get that, 25 minus 5 will give me 20. 10 minus 2 will give me plus 8g. And we have no f, and we're minusing the 1, so we're going to have a minus 4f. The c's will cancel, and we'll be left with 0. That's right. Yep. Perfect. Now, the second one, I'm going to do the third equation minus the second equation. So 65 minus 25 is going to be 40. 2g minus 10g is going to be minus 8g. Minus 16f, and there's no f in this, so it's going to be left with minus 16f. The c's will cancel, and we'll do 0. I'm just doing simultaneous equations here. I'm not actually writing out each equation and then minusing from the other. I'm just looking at them, but because I'm running low on space. But yeah, anyway, you're going to see these 8g's are going to cancel, so I'm going to be left with 60 minus 20f is equal to 0. That means that f must equal 3. So we have f equals 3. And if f equals 3, we can just fill into one of these two equations. 20 plus 8g minus 4f is equal to 0. If that's the case, that means 20 plus 8g minus 4f is going to be minus 12 is equal to 0. And that would mean g must be 20. 20 minus 12 is going to be 8. Bring over the 8, divide it, it's going to be minus 1. So g is minus 1, f is 3. Now we need c. To do that, we'll just fill into one of these 3 original equations. I'll do the first one. So 5 plus 2g. So 2g is going to be minus 2. 5 plus 2g plus 4f. 4f is going to be 12. Plus c is equal to 0. So that's going to be it's going to be 15. 15 plus c is equal to 0. So c must be minus 15. So we have g, f, and c. Now we just fill into our equation. So we have x squared plus y squared plus 2gx. So it's going to be minus 2x plus 2fy, f is 3, plus 6y. And then we have the plus c, or is it minus c? No, it's plus c. Yeah, plus c. But our c is a minus 15, so it's minus 15 is equal to 0. And that's the equation of the circle. So just remember, all you have to remember, if you're given the points and you need to find the coordinates of the circle, or the equation of the circle rather, fill in the coordinates, get your 3 equations, do simultaneous equations, move on. Done.